Yeah. Hi. Two things. One, did you get my email submission? Do you remember about me sending it to Activity 1 through email?
I'm sure I did. Did you ask for a return reply?
No.
Okay. If you want to make sure, you can send me another email for a reply. I always assume people get it, so sometimes I give a little like thumbs up.
Oh no, you liked it. That's
right. Yeah, that means I got it.
That's funny.
Okay. And second thing,
would you mind if I left around 4:30? I have to help my friend go get his phone.
Sure. Actually, we're going to end a little bit early, so you'll be on task. Don't worry. Okay. And of course, I make a video, so if you have any questions, feel free to watch.
I also was on your last class. What did I miss?
If you want to watch the video, it'll be on there, okay? But it's probably in the notes too. Sure. No problem. No problem. Okay. Okay, so why don't we get started? So I want you to go ahead and open those two data files. And what we're going to do today is we're going to finish talking about chapter 3. We're going to do a little bit more next class, but we're going to finish talking about the standard deviation as a measure of dispersion. So we started talking about that last time. And so one of the things we want to do is we want to talk about application. So we always say everything we do in statistics always has an application, right? And ostensibly we want to measure the spread to see how wide the data set is. But why do we want to do that? What is the application of understanding how wide the data set is in real life? So first thing we want to do is we want to look at the fact that in business, variability really has to do with consistency. And so in any sort of business, you always want to have the product, performance, the quality to be consistent. And so this is just kind of a simple example we can look at. Suppose you had two different brands of outdoor paint, and you want to test to see how long each one's going to last. So this is the data. So this is the first brand, brand A, and the first sample that you tried lasts 10 months. Second lasts 60 months, and so on. And then you have a second brand, brand B, and the first sample here lasts 35 months, 45 months, and so on. So let's go ahead and download that data set. Look at that in StatCrunch. So go ahead and import that from modules. here's what the data file looks like. Now, what sort of plots can we make with this data? Make a bar plot, a pie plot? Can we do that with this data? What do you think? What sort of plots? These are the sorts of questions on the exam you're going to be asked. I'm going to give you data and ask you what sort of plots would be appropriate. What sort could you make? Can we make a pie plot? What do you think? No? Why not? What's that? Why?
It's not really a percentage.
Well, I mean, if you look at, for example, like responses for presidential candidates, are you going to vote for Trump, yes or no? Those don't have percentages, and yet we can make pie plots of that. What's different with that sort of data as compared to this?
It has a total number of participants. This one's just a sample. It's taking two brands and seeing how long they last over time.
But what is the difference between those two? When you're taking people to look at what percentage are going to vote for a candidate, that's only a sample also. What's the difference between that sort of data and this sort of data? The data type. So what data type do we have here? Quantitative. With quantitative, we can only make certain types of plots. We can't make bar plots, we can't make pie plots. That's for categorical or qualitative, right? So what sort of plots could we make here? Dot plot, okay. We can make what else? In principle, what else could we plot with this? Box plot. Box plot, one more. Which one's correct? Only one of those three is actually good to use here. Probably the dot plot. And why would the dot plot be best?
Because you can see the distribution better.
So dot plot's the right answer. I'm looking for kind of one key factor here. What is it about this data set that makes a dot plot more appropriate than say a histogram or a box plot?
It's talking about spread.
They're all going to give us spread in some shape, way, or form, right? They're all going to give us that.
Is it because each data point is more isolated?
And why is that?
Because they're just specifics. It's not really being.
So here's what I'm fishing for. The sample size, right, makes a big difference. If I had 1,000 data values, I wouldn't make a dot plot. I'd make a histogram or a box plot. When I have less than 10, hands down, every time we make a dot plot. Because why? Because we don't have enough points to kind of fill out that curve, right? You need at least 5 or 6 bins for a histogram. You only have 6 data points. There's no way you're going to really make a good histogram, right? So let's go ahead and make the dot plot. So we're going to make a stacked dot plot here. We'll go under graph, dot plot. Whoops, come on. Dot plot. I'm going to just choose them both. And then down at the bottom, we'll say 2 rows. So we'll make them stacked. Okay. And there's our dot plot in all of its savage splendor. Everyone's getting that? Now you notice there's an option to put the mean and the median on that plot too. If I put the mean and the median up there, do you think they'd be roughly the same for those two, or would the mean and the median be really different for one data set, or what do you think? They'd be the same. Why?
Because even though the spreads are different, they're still directly.
What's in the middle? So you said the word. What's the word? Right. So we have a symmetric distribution, right? So if we went ahead and plotted those medians and means, let's go ahead and do that. Let's go back and edit our plot and just put them in. Convince you it's not a figment of my crazed imagination. Bink, bink. And sure enough. And in fact, they're so much on top of each other you can't even distinguish it, right? So that kind of comports with what we think we should see. Good, good. So let me ask you a question. So now we have the plots of these two data. We kind of know what the distribution is like. Which one would you buy? Or if you were making it, which one would you want to put out? Would you want to put out brand B or brand A? Okay, and why brand B?
Because the product is more consistent.
And why is consistency so important in business?
Because without consistency, you're going to lose. Without consistency, you're going to lose customers because they're not going to get the same product or the same service every time they come back.
And that's really the problem. Look, you might say, well, hey, this guy got 60 months, 5 years. Great, you know what? He's going to buy your product again. But what's he going to probably get next time? He's going to probably get down here, right? And then what's he going to do? He's going to go on social media and he's going to complain. Things like TripAdvisor and Amazon.com, those things, especially when you get to ratings that are more select but aren't as many, things like TripAdvisor and stuff like that. Those ratings are really important, okay? So we always want the customer to have the same experience. That's why when you go into Walmart, right, it's always the same. Same layout, the same design. I think it's the same people even, right? I mean, everything's the same at Walmart. Why? Because they want you to have the same experience. Yeah.
Mine is not.
I'm sorry?
Mine is not looking good.
Okay, well, we'll done.
They have. So, sorry if I'm.
If you guys could work with someone else, I hate to see you not both. Can you work with somebody else? I don't know. You want to work with someone else? It might help. It couldn't hurt, right? Okay. So good. So okay. So in business, we don't want variability when it comes to performance. What about finance? So it turns out in finance that we actually have a name for variability. We call it risk. If, for example, you have any sort of financial instrument, a stock or whatever, if it's highly variable, it's highly risky. We don't like that because you can't predict. You might get really big results, you might get really terrible results. When it's your money or someone else's money, you don't want that to happen, right? And we actually have a name for this. So you might have heard the word volatility. Volatility is actually a technical word. It stands for the standard deviation of the Standard & Poor's logarithmic return. So let me just kind of show you what this is. This is kind of cool. How many people know what the S&P 500 is? Let's just show hands. Anyone want to enlighten us? What is the S&P 500?
I just heard of it.
That's okay.
Essentially, it's like some of the top average 500 companies based on how their stock prices are doing.
So it's an index of the stock of 500 leading companies, and they're actually diversified. It's not like the Dow Jones, so it's actually supposed to be a really good indicator of the market. So
They call it the backbone of the Wall Street.
what's that?
They call it the backbone of the Wall Street.
Okay, I believe that. So this is basically some sort of conglomerate index. This is in dollars. This is what basically found with the stock holdings for the S&P 500. This is what it opens at on a given day. This is what it closes at. And what you're really interested in is that ratio. Okay. So here, notice that it ended the day better than it started. So when you take this ratio, it ends up being greater than 1. And what they do is they take the log of this. And the reason why they take the log is the log of 1 is 0. So when the stock ends better than it starts, the log's positive. When the stock ends worse than it started, like here it started here, it ended a little bit worse, the log's going to be negative. So that way you can kind of really see how it performs. Positive means it gained during the day, negative means it lost, okay? And it turns out that the standard deviation of these numbers is literally the volatility. That's how we actually define market volatility. So let's just go into the S&P 500 data set and download. So this is the S&P 500. It should be right here. And while you're loading that up, I'll tell you a little bit of the context. So the S&P 500 statistics are really easy to get. I mean, almost any sort of major financial site has it. I got these off of Yahoo Finance. So you can go to Yahoo Finance, and basically this is the S&P from January 31st of 2000 all the way down, every trading day till January 30th of this year. And we want to look at the log of the market returns here, okay? So I have over 3,000 data values. Which way should I plot this data? Dot plot, box plot, or histogram? Definitely not dot plot. So we have our choice, histogram or box plot. Usually histogram is better initially, because what can a box plot miss that a histogram can show you?
Yeah.
Actually, box plot will show you outliers better, because it'll show you the little dots, right? But what else will a histogram show you that you could miss on a box plot? Right, if you have a bimodal or a multimodal distribution, you generally won't see that in a box plot.
Why wouldn't you want to do a line graph?
You could do a time series. Is that what you mean by a line graph? Sure. We could, yeah. But right now, if I just want to study the volatility, that's how we actually define it. We kind of conglomerate. We look over a fixed period of time and we kind of look at them all together. Oh, but yeah, time series in finance is a big thing.
Would it be too large for a contract?
What's that?
Would it be too large for a contract?
It depends on how you plot it. I mean, for a time series, this would be like, if you want to study historical trend, you could.
By days on here, so that'll be.
I mean, you could plot it. It would be almost like a smooth curve. You wouldn't even see the days. But we're going to go ahead and just plot a histogram for right now. Unfortunately, we're not going to get the time series, and it's kind of a shame because time series are really cool. So there's our data set. There's the plot. And by the way, when you make the plot, always use relative frequency, okay? So plot this using relative frequency. The one thing that will happen is the scale on frequency is really big. Relative frequency will bring the scale down, and it'll let you see some of those really far outliers. That's really good. Right. Do you want to look up at someone else? So pop quiz. Suppose I ask you on an exam. Suppose I ask you on an exam, describe this plot. What would you say? How would you describe it? Symmetric unimodal. What else do we have to report? So there's kind of a question here as to what's going on, right? Is this part of the tail or are these outliers?
It's an outlier.
So it's not so easy to see. What you'd have to actually do if you were doing this professionally is you'd have to go back and actually investigate. So you would go back to the Excel file, sort it, and you'd look to see what was going on. Maybe this was when there was something really catastrophic going on in the market. Like maybe, I don't know, when Trump got elected, right? The market went down a little bit, okay? Maybe something like that was going on. We have to check it out, okay? So it's not so obvious. The center, what would we report, the mean or the median here? They're probably both the same, but technically we'd use the mean, right? Because it's symmetric. And what about for the spread? How can we report the spread of the data set? What are our options here? Okay. What are our options for the spread? I asked you on an exam, tell me what the spread is. What would you say? Well, one option is the range, okay? We don't want to compute that for the spread, right? We want to compute it, but we're not going to report it for the spread. The other two are the IQR, the interquartile range, and the standard deviation. Which would be better here and why? What do you think? Standard deviation, and what would be the reason for that? So both for the center and the spread, what we report really depends on the shape, right? So here we have a symmetric distribution. When it's symmetric, we're going to report the standard deviation. Okay? And if you actually do that, if you compute it just really quick, it won't make a lot of sense because we don't really have much intuition as to what it should be, but the standard deviation ends up being 0.005 here. Okay. Remember what the standard deviation is? The average distance of the point from the mean, okay? So again, we don't have a lot of intuition on what that is, but that's on the average log return from 0 is 0.005. Okay. So any questions on this? Just kind of the basics of plotting and so we tend to think of the standard deviation as kind of like the average distance of the data points from the mean. Kind of giving us a measure on average how far the points are from the mean. And we're going to use a standard deviation a lot. It's going to do a lot of heavy lifting for us. All right, good. So, I'm not synced. Hold on. So brief review. If we have some data set like this, okay, the range is the smallest minus subtracted from the largest value. We always compute it. We want to get an idea of what the range is, okay, but we don't use it for the spread. So we can use the interquartile range, which is exactly like it sounds, right? The interquartile range is the range between the two quartiles, interquartile. It tells us the range for the middle 50% of the data, or with the interval the middle 50% of the data is contained in. And finally, the standard deviation. So we look at each data point, we subtract its difference from the mean. We take all those distances and square them, and divide by 1 minus the sample size. That gives us the variance. We take the square root of the variance. Okay. So that's pretty much measures of dispersion in a nutshell. When to use which? Okay, the whole thing really here is a shape. Okay, outliers are strong skew. We report the median and the IQR. Symmetric, we report the mean and the standard deviation. In real life, very often things are slightly skewed. So what do? If you're in doubt, do both. That's kind of the honest thing to do. What most people tend to do is they tend to trim the data set. They take off the 10% highest values, the 10% lowest values. They recompute the standard deviation. If it changes a lot, that means those extreme values were really having an effect. And then we use the IQR. Okay, that's the idea. Any questions about measures of dispersion? Everybody's good? All right. Let's go ahead and take a quick break, and we'll come back and start on talking about activity 1 a little bit.
Yes, sir. Sir?
Yeah.
Did you say the definition of volatility was?
It's the log. It's the standard deviation of the log of the market returns. So what it is actually, what you do is, so the idea is that you have some fixed time period, right? So like, if you wanted to look at the volatility in January, okay, you look at this ratio, close to open on each day, okay? And the idea is that you would add up, you would look at these, so you'd have these ratios of close to open for each day, okay? And the idea is that you would compute the average of these, I'm sorry, you take the log also, sorry. The log of the closing to the opening, you take the average, and then you compute the standard deviation. And the standard deviation of the log of that ratio is the volatility over that period of time. Not obvious, but the reason why, like I said, the reason why the log comes in handy is because when you have a good day, it's positive. When you have a bad day, it's negative. So it's kind of easy to watch what's going on. We actually have a guy here. His name is Tim Smith. He studies this. He's really big into market volatility, bubbles bursting, and all that sort of stuff, housing bubble and whatnot. So. That's what it is. I'll start the roll back with you when we start out. Thanks.
His name is
Oh, no, sorry.
Yeah, but that would
It's actually,
like,
it's Q1 and Q2.
but this is like an
And then
analytical.
Q2 is the
It's not like
median.
a.
I'm just trying to remember, like, I'm getting this email and asking.
Oh, yeah, you basically take the data values and sort them, and you find out what 25%.
It has to be.
That's all this is. But next week, we're going to go to stat function.
No, I got that now.
Technically, there is no one value in the 50. So you have to take like 26 and then add it 5. So like, technically, mathematically speaking, there's like no several trains. So we take any value, so we kind of choose a convention. We just say, oh, this is out. Well, the same is true as calculation. There's formulas, but it turns out like if you have files, you can actually have slightly different formulas. That's what I want to do. And so, but in reality, it's like, so that's literally oh, so it's not major. It's not. Okay.
But you do have.
I mean, at the end of the day, they're asking me anyhow, so, and no one really uses it because it's more really hard.
And I am wondering, what is our test code? Because the things we learn here are, like, it's not that they're not relevant to what we learn in computer science, but they're completely different.
Because of the example.
Like, when we use the
If you know the notes and you know the homework, you're sitting on
Okay, all right. So I know we definitely did it, but I don't want to expand each of the 4 hubs. Okay, all right.
Better safe than sorry. Okay, so let's pick back up, okay? So I want to go back and look at activity 1. We want to kind of think about what we're doing in a kind of holistic sort of way. It turns out that section 8 and the rest of the class, they kind of start talking about inference, and it's not so obvious like where this actually starts. So I want to discuss this in some detail. So let's go back to the big picture of statistics for a minute. Kind of think about where we are. So we said, okay, the first thing we do is we pose a question. We saw from the activity, actually, there's a lot of thought that goes into that, okay? So we had to think about things like, you know, what is your population? We found out that a population is not necessarily a group of people. It's just all the things you're interested in. Then you had to think about what were you interested in? Okay, that's your variable. That's what you're actually going to measure in the population. And what we were really interested in is this plot right here. This is the distribution. If I was an omniscient being, I could know all those values, right? That's what I'm really interested in. And the thing that I wanted to get from that is this thing called a parameter. This is a number that describes the shape of this plot, and the particular parameter we were interested in was the center. So there's a lot of thought that had to go into that, right? And it kind of took a while for us to figure out what these different terms were. Then we talked about data collection. And we saw that data collection was a really big thing, right? I mean, we had, first of all, the sample that we picked by eye. And here's the data for the entire class. So these are all the apartment sizes that all of you picked. So for example, you picked 5 apartment sizes, you picked 5, you picked 5, they're all in here. Now let me ask you a question. When you compare the true distribution of the building sizes with the ones that you chose, what do you see? Do they look the same? Or are they different? And if so, how? What do you think? There's some similarities, but what's one of the differences that you see here? if you look at it carefully. Okay, what I want to know is, if you look at the apartment sizes that you picked and the actual apartment sizes, these two aren't really the same. The question is, how do they differ?
Yeah, I mean, they look similar, off by a lot.
The averages are off, and so let's kind of look at the shape, because the shape determines the average, right? What is it about the shape of this that's different than this? What do you think?
The mode is a lot smaller.
Okay. Let me ask you a question. How did you choose the apartment sizes? Did you have like a rationale or some way of doing it? How did you do it?
I just picked random ones.
But how did you pick them? That's the thing.
I moved my hand around.
What's that?
I just moved my hand around.
So you kind of did you close your eyes and randomly pick
No,
them?
it was with seeing. There was a little bit of bias, but you can't get rid of that.
Okay. Anybody else have a method? Yeah.
I was saying what it was activities that people kind of gravitate towards the games like the first one, you kind of see the first one's always the one with the public corner, all those small buildings.
Well, and we certainly see that. We see that we kind of have a little bit of a bias towards the larger buildings, right? You can see that all these percentages, tend to be higher. And that's not too surprising. We're kind of hardwired to see big things, right? If you ever go into a room, there's like a professional football player, basketball player, your eyes immediately go to them. We see big things, right? Evolutionarily, we probably had to get away from mastodons. We're more concerned about that than rabbits, right? That kind of makes sense. What else do you see? There's something else that you see. So let's see, who else, how did you choose them? Go ahead.
Choose the apartment.
Mm-hmm.
Just like get rid of the smallest.
Okay, so when we chose them, how did you do it? When we chose your 5?
Oh. Like I just think it's like quite a middle size.
Okay. So you tried to find ones that weren't too big and weren't too small, right?
Yeah, that's
Okay. That's one strategy. Anybody else have a method? Hey.
Actually, you got lazy.
On the same row.
Yeah.
That is lazy. Yeah, you're right. Anybody else have a method?
I just didn't even look at the map. I just kind of picked a letter and number at random, and that popped in my head.
Okay.
So I didn't look at the map at all. Was not to get bias based.
Okay. So you did it more kind of like the computer, right? Okay. Anybody else on that?
I tried to pick a good balance of small buildings and large buildings.
Yeah, and if you notice, one of the things that you'll see if you look at this carefully is that this is more uniform than this. And this is another sort of bias that we have. In fact, there's a thing called Benford's Law. This is how they catch people when they cheat, the IRS and financial companies. What they do is the financial analysts know that the number 1 occurs most commonly in financial statements, then 2, then 3, then 4, then 5. So the distribution is quite skewed. But what happens when you cheat? For example, I go online and sometimes people ask for information, I don't want to give it, so I just make up stuff. How do you do that? Well, you choose one number like 1, right? Then you say, I'm going to choose a high number like 8. Let's see, I chose 8, so now I'm going to choose 5 to try to make things kind of even out, right? And that's actually not a bad play. I asked you to choose representatives, right? So you chose a small, a middle, large. The problem was that the distribution wasn't like that. The distribution wasn't even. So we're kind of seeing that. Notice that we oversampled the smaller ones because of that. So it was a really good strategy, but it wasn't random. Okay. So a lot of things go into sampling. And what we ended up seeing from this whole thing is that the reason why we care about how we sample is it has to do with accuracy, right? So we said, okay, this is the thing that we were trying to hit. We were trying to hit the population mean. But what happens is, because we're not sampling from the population correctly, what ends up happening is our values are centered around a different position, okay? So here's our sample mean for our class. And this difference is actually called a bias, literally, because we were biased toward the larger size, okay? The larger sizes. So what we saw that the sampling method affects the accuracy. If we want to have values that are well clustered around the correct value, we have to sample properly. So now we're at the last stage, which is descriptive statistics. And at this point, you really know how to totally describe a data set. You know how to take a data set, how to plot it, you know what to look for, and how to describe it. If this is where statistics ended, it wouldn't be very interesting. I wouldn't do it for a living. Because it's kind of like taxonomy. There wouldn't be a lot of interesting stuff. So this is kind of like a turning point in the course. Now we're going to start talking about inference. So we want to start talking about this thing called a statistical model. And what a statistical model is we're looking at the distribution of a population. That doesn't mean a lot right now because we haven't worked with this. But what's going to happen is that's going to let us to make our decision about the population. So it's really important to understand, although this stuff won't make sense, you have to understand that here we're looking at data, okay, from a sample. Here we're making a decision about a population. The two are very different. For example, when you're looking at like political polls and they're asking what percentage of people are going to vote for some sort of national candidate, there's 150 million registered voters in the US. The population's huge. How many people do they sample to get statistics? 3,000. Now, both of those are large numbers, but think about money. Would you rather have $3,000 or 150 million? There's a huge difference, right? So how we make this leap from going from 3,000 people to generalizing to 150 million is really a big step. And that's why we need this. Okay? So let me kind of just explain really briefly what we're going to be doing here. So here's kind of the question. What sort of decisions are we going to be talking about here? And it turns out there's two different types of decisions we're going to be thinking about. The first is a decision about an individual. One thing from the population. When we actually know the population. We've been saying up to this time that we generally don't know the population. That's often true, but sometimes we do. If you work for a company, if you work at a school like Embry-Riddle, they have statistics on everyone's GPA right now. Databases let you store a lot of information. So sometimes we do. And here's the sort of decisions we want to make. Suppose you manage a division and you have to lay somebody off. Okay? So there's Bob in IT and there's Barb in accounting. And both of those supervisors come to you and say they're underperforming. Who do you lay off? Okay? How do you decide which one's worse? I know everyone says the IT guy, but you know, but that isn't the kind of thing. The problem is you can't compare them directly, right? They're apples and oranges. One person does accounting, one person does IT. So how do you decide? You have two job offers, okay? Maybe one is in New York City for 70,000 and another's around here for 55. These numbers are not the same. 70,000 in New York City is not the same as 70,000 at the beach. So again, how do you compare these two things? They're apples and oranges. So what we're going to see is that this is kind of linked into a concept called relative standing, which is a really easy concept. So let's kind of go back to this example of two different salaries, okay? It turns out that for salaries, you can actually get pretty close to a population. You can go on the Census Bureau. They have really good data on salaries. And suppose, for example, this is what the salaries in New York City look like, okay? So most of the salaries are around 50 to 70,000, and there's your salary that you're offering at 70,000. And let's suppose this is the distribution for Daytona Beach, okay? These are what the salaries are distributed. Kind of like a histogram, right? And maybe here's your salary at 55,000. And here's what we're going to look at. We want to know, where does that salary sit relative to everyone else? So suppose, for example, in New York City, you make more than 84% of the people. Suppose in Daytona Beach, you make more than 97% of the people. Based purely on monetary considerations, you choose Daytona Beach. You have more spending power, right? So you can buy more than 97% of the population. So your standard of living is going to be better. And this is the notion of relative standing. So if we know the population, right, I can tell where my value stands in relation to everyone else in the population. And that's the concept of relative standing. And that's what we're going to talk about next time. But that's actually pretty easy. Now, here's the harder thing to kind of get your mind around. This is the hard part of the course. Sorry. This thing keeps going out for some reason.
Sorry about that. Let's do this.
The other sort of decision we want to make is we want to see if the populations change, or we want to compare two populations and see if they're different. Okay. So, for example, maybe you start an ad campaign, and you want to see if sales have increased. Now, all of us are data savvy enough that you know you don't compare individual values, right? You look at what's happening on average. So I want to know, are the average sales before the campaign less than the average sales after the campaign? All of the aerospace industries are starting to fabricate their own parts. Okay, so suppose Airbus wants to start a new fabrication plant, and they want to ask, is our time to make a part going to be at least as short as our previous vendors? You want to give your employees a training seminar. Here's what you're looking at two different populations. You want to know, have they improved? So what was their performance before, their average performance before, their average performance after, okay? And this concept is a lot more subtle. This is the most important concept in the entire class, the sampling distribution. It's also the hardest thing to get your mind around. So if you get this, you'll understand 95+% of statistics. It really is that important.
So let me just show you really briefly. We're not going to talk about the sampling distribution for a couple of weeks, but let me just show you kind of the idea. Here's the idea behind the sampling distribution. Let me get this to work.
Okay. So this was, again, going back to activity 1, okay, these were the actual areas of all the buildings. These are the areas of the buildings that the computer shows. Notice they're very similar to the true distribution, okay? So the computer did a much better job than we did. Not surprising, right? So this is an example where we've done a really good job of sampling. So these are all 48 buildings. These are all the buildings that you chose with the computer. Okay. Now, these are the average apartment sizes chosen by the computer. So, like, you had 5 computer chosen, you computed an average, you did, all of you did. These are all of your averages, average building size of the computer. Does this distribution look like that distribution? Absolutely not. So this is a really important concept. It's the concept that the sample mean has its own distribution. It's not the same as the distribution of the apartment size. The average apartment size has a different distribution. And what that distribution is, we're going to spend about 2 weeks talking about. It's a really important part of this class. So that's where we're going. Okay, last thing I want to do today, we're not going to go any further as far as material. Last thing I'd like to do today is I always like to get feedback throughout the class. Here we are. For example, you give evaluations at the end of the class. They're really helpful, but the problem is it doesn't help you because the class is over, right? So usually I do a midterm sort of evaluation or questionnaire, but then I find it's like gone back and forth. I like to kind of have a conversation. So what I kind of want to know is, hear from you, like what's working, what's not working, what do you like, what don't you like. If we can make changes, we certainly will. So I'm just going to open it up to you guys and ask for your thoughts. And please be honest, okay? Constructive criticism is good. I totally love it.
Paying $110 for a book.
Yeah, I guess you do that for a lot of courses. Plus, you get more. You get the homeworks, the quizzes. I mean, think about all the advantages. You can take the exams on your own time. You can take the quizzes on your own time. You have extended time. I mean, I'd like to think it kind of balances out, but let me know what you think. Do you think it's like it's just not worth it? You'd rather have in-class exams?
But it's a bit much.
Okay.
If you make it like class and without that book.
I could, but the problem is you wouldn't get as much help on the homework. You wouldn't get the exams back right away. You wouldn't get instant feedback. I think you'd lose a lot. I think
StatCrunch is good, and I do like the book. Even though it is 110, I do think it's a valuable resource. The only thing that I find that it's not confusing, but it's a little different is the fact that what we learn in class isn't necessarily what we're doing outside, what we're doing with that.
Okay. And that's kind of by design. I mean, I hope it's not confusing. I like to think that what I'm trying to do is kind of explain what it is that you're doing. The homework is just you're just computing things. Okay? It says compute this, compute that, and my goal is I want you to kind of understand what you're computing. So hopefully they're not like totally disconnected. I hope not.
I don't think so. I like the current format personally. I think it's a good blend.
Okay, I mean, and I do think that most of the stuff that's in the notes kind of is in the homework, like the stuff we're talking about, with what the standard deviation is. I do try to keep it close to the book, as close as I can. So we'll see. If you think it's deviating too far, let me know. Okay. Other comments? Yeah. Please.
Canvas, when you chop up the lecture you post, and everything, it's all in the same group. Usually, professors like to chop up chapters like this up, maybe chapter 1.
Right. You know, and someone else mentioned that what they said that might not be a bad solution is to just put them in the folders. I don't know, would that be better?
Yeah, if there was like a chapter 1 folder with the lecture, notes, video, and everything like that.
I can do that. Someone from another class suggested that, so that's a really good suggestion. Thanks.
Other things.
I like it being online.